Yeah, not sure where I really need a microphone, but I will use it anyway. And oops, does it work now? It's not. Somehow, oh, it is. So yeah, before anything, this is the QR code to this slide. We have more than 100 slides, and when I say more than 100, I'm not joking. So we have 5 seconds for this slide. Yeah, so I believe everyone's here for chaos, but yeah, the truth is it's just to try to attract more attendees, and this doesn't seem to be a good enough. Oh, why chaos? Yeah, doesn't seem to be a good strategy. So yeah, anyway, we're still going to build like standard linter first. Yeah. So why do we need it? Because we already have rough, black, and PyLint and flathead and all those kind of stuff. Why do we still need it? Because sometimes you just have some like customer rules that you need in your specific project. So yeah, I'll introduce with a real world use case. This is back to the time I introduced this feature to Airflow. You don't actually need to know what this feature is. So the idea is the default value of that argument differable need to be set as this giant something. Yeah. So these are the examples that are not allowed. If differable is set to true, it's wrong. And if there's no default value for differable, it's also wrong. So only this case can be correct. So what can we do? Yeah, we are just too lazy to do the manual check. So that's why we build our own linters. And that's the pull request I made back then. So we use the AST module. And what actually is AST? So it stands for Abstract Syntax Tree, a way to represent your Python code. Yep. So this is an minimum AST example with the source code as a equal to 1 plus 2. And AST pass it into a tree, and I dump it. So yeah, so you can understand. Otherwise, it would be just an object. Yeah, no one knows what that is. And under the hook, it looks something like this, and I visualize it a bit to an actual tree. So here, it's an assignment from the module, and it's an assignment, and after that, you can get the target value you are going to assign. Where there's a nan ID as A, and there's 1 plus 2 because it's a binary operator plus. So yeah, it's a constant 1, and this is the add operation, and it's a constant 2. And yeah, go back to our example. This is what we want to check. And if you want to see how the tree looks like, it's such huge, even for such a super easy sample. But yeah, we are going to formalize the requirement a bit. So again, we are going to check the default value of differable, whether it's this giant thing, and formalize it. If we want to do search for all the class definition and the dunder init method and the argument differable, if we find it, we'll check where the default value is set and whether it's set correctly. Yeah, and we can formalize it into the AST term, because in AST class definition is a class def node, and function node are function def. So we'll need to search the class def nodes, and then within them, we'll try to find the function node with dunder init and the argument and blah, blah, blah. So let's see the code first. We already passed the module file, and then we try to iterate the whole AST object. And we'll check where it's a class definition. And within that, we'll check whether the function definition is dunder init. And if it is, we'll go into this function. And because AST does not bind your default value with argument together, so we'll just need to do it ourselves. So that's why I use the lib longest to combine them together. And the following are the conditions I did. So yeah, because it's not differable, it's nothing we want to check. And if default is none, because there's no default value, it's incorrect, we'll just report it. And for here, we are going to check whether the default value is correct. And to check whether it's correct, we'll first check whether it's a code, because it's a super huge thing. What was that again? Get boolean. Anyway, so it's a long check we need to do. But afterward, I found out, hey, we can just unpass the default value, where the default value is equal to the get boolean operator, default operator thing. So yeah, I did many of the experiment, but we don't actually need to do that. And where we can do one step forward to do some like auto formatter, because contributors are somewhat lazy. So we don't want to scare our contributor of Airflow. So we try to build an auto formatter. And it's built in AST as well. So there's a node transformer. And previously we used all those kind of logic. Actually, we can use node visitor, but yeah, the logic is pretty similar to node transformer, so I'm not going to walk through that again. I'll go to node transformer directly. So you'll need to define your customized transformer class and inherit from this one, and you'll need to define your visit function. So basically, by visit function depth, it will try to iterate through all the function depth in your AST tree. So we think I know it's really small, but it's the core logic of it. It will try to check whether the default value equal to the expected default AST. Yeah, and once we do the default differable transformer, I forget to, So basically, if it's not, we'll try to assign the expected default AST back to the node. So now differable will be assigned to this expected default AST with like conf.getBoolean, all those giant stuff. So this is how we use it. We initialize it, and we try to visit the AST tree. And because when you try to write back to the AST, it will change the code location. The AST itself, we add 4 lines of code back to the AST. The line number will be changed. So we'll use fix missing locations here. And we'll just write the unparsed AST back to our file. So this is something we are going to fix. But it's fixed, but the format are all gone. So we probably need to go with other methods and check it's right. libcst is the way to go. And why? Why do we want to use libcst? Because it preserves more details. And like this one, it passes the a equal to 1 plus 2 and comments, and same for cst. AST tree just looks like this. As you can see, there's no comments, there's no spaces. But for the same code, the libcst pass it as such giant stuff. You don't actually need to know the details, but the idea is still the same. And I also visualized it a bit. And here is the mainly different part, the trailing space here and the comment with comments, and the new line as well. So that's how libcst try to preserve all the details. And it also provide more features like more provider. It's provide you with the position data and also the expression context and what's the scope of this variable and all this kind of stuff. And also code module that you can just gather the input because you probably would like to remove unused input and so what, and why not just remove that? So let's try this again. And with CST transformer, the logic is still pretty much the same, but this time we use leaf parameter instead of visit. And it's in CST, they actually combine the default value with their parameter, so we can just use it much more easily. So we'll compare whether the node we want to update it is the same as the expected default CST, the default value we want it to be. If so, then we'll just skip that. If not, then we'll just change it here. We'll update the tree and set the default as expected default CST. And we'll just use the similar way. We'll just pass the module, we'll read it, and use the tool to visit it, and write it back. And this time, it does not change anything. The comment's still there, the quote is still there, and everything's there. But except for it's super slow because it preserves so many details. So in our example in Airflow, it took like almost one minute to pass the 400 modules, but AST took like less than 1 second. So this is what I did. I tried to filter out the modules we actually need to check, need to update it, and use libcst to do the actual update. So yeah, this is what I did in this pull request. And we'll take a look on what other tools do, like Black. Yeah, I tried to trace the code of Black a bit. They are still building their syntax tree, but they are not doing it with AST or libcst. They actually use lib223, even though it's already deprecated in the main C Python, but they have their own code version anyway. So they'll first standardize the lines and try to pass it into a syntax tree and try to tokenize it. And it will return a syntax tree as a node object. If you click the link on the slide, you'll just go to the Black source code there. And it will generate the line object through the line generator it provided. And it will translate it back to the expected line block by Black, because Black has its own preference, so it can just generate whatever it wants. So that's the super high level on how Black works. It built the A plus E, 1 plus A equal to 1 plus 2 like this. So that's the syntax tree, and it still preserves all the needed information here, and it will generate a line object like it and try to unpass it into a Python file that we can use. So why is Black fast? They are trying to use MyPyC, and yeah, I didn't investigate MyPyC, so I don't know what it works under the hook. So that's Black. And how about Rough? Yeah, back to the time I promote my talk, I said, yeah, I might be able to include some Rough content. And some of my friends just said, whoa, there's more Rust, and that will be more interesting. But I don't actually know Rust, so yeah, I'm sorry, Yarik. Yeah, but even if I only have limited to no Rust knowledge, I still be able to contribute to some of the airflow rule in Rust. So if you take a deeper look to the Rust folder, there's actually a lot of Python AST related stuff. And yeah, these are just the nodes we have in Python AST. And if you take a look at the code itself, it's just direct you to the AST documentation. So yeah, here's a minimal example on how I implement some of the Airflow related rules here. We deprecate this class in Airflow 3, and we'll try to warn our user to use another class. That's what we are trying to do. And this is a function we make. So basically, it's check whether the name has been deprecated and we want to replace it with a new thing, or we just want to remove it. So this is the function. So the first step, we actually try to check whether the name, the full qualified name of an object, like if we call dataset somewhere, we want to know it's actually from airflow.dataset instead of other dataset, because the user could possibly just define a dataset class. So that's the full qualified name. And we'll just use somewhat like a if-else loop to check where it's actually airflow.dataset, and we'll replace it with the new name we want to. And we'll just push the arrow back to Rough, and Rough will handle all those kind of fancy stuff. They're fancy, like terminal user interface and all those kind of stuff. So that's it in our super high level, and now you can be a contributor of the Rough based on the knowledge we have. But yeah, I already promised you to bring some chaos, so I'm still going to build a super simple chaos linter. So yeah, how does this mean? Yeah, so every time I saw KAS or all this kind of nonsense, I just, why do people do that? So that's mean how about get some numericons. So yeah, let's setting up the rules first. We'll just skip buildings, because if you change the name of building, it just won't work. And if you change your Dunder methods, it won't override anything. So we'll skip that, and anything imported, because yeah, you are not going to import the correct name. It just don't work. And we'll only change all the top level variables and classes and function names only. So here's how we do it. We first check whether the nodes is actually a Dunder method built-in and some other nodes we want to exclude. And we try to gather all the import s and from import s and try to skip all these names. And we'll try to visit all the class definition and build out a mapping where we want to map like a function name. If the function name is native funct, and we'll rename it as F2C. So this is how it looks like. Yeah, we'll visit the node and we'll check where it's excluded. If not, then we'll just add it to the mapping names to change. Yeah, this is how we generate all the mappings, and we'll try to check where it's private, because it's private value. We are not going to change it to underscore. We are going to change it underscore F2C instead of underscore 2C, something like that, or it's protected. Yeah, so that's how I implement the logic. And this is implemented with the CST transformer. And yeah, it can change itself into this kind of nonsense. So yeah, there's some limitation to this implementation, or something I just too lazy to actually implement. If there's name collision, it can't handle that. Like if you have to func and another word is also F23, and they'll be viewed as the same variable. And if there's some scope issue or inheritance issue, it won't be able to handle that because I don't want to. It's just a simple example to demonstrate we can do use AST, the concept, to change the code for any kind of customized need. So yeah, if you want to bring chaos, it's still need some time to do it correctly, but I think it should be fine. So I actually wrote a few blog posts related to this one. So if anyone's interested, you can scan this QR code. Yeah, there's 3 posts I still need to write, but I'll try to finish them. And yeah, these are some related PyCon talks. One from PyCon US last year from Charlie, the creator of RAF and UV, and Lucas. I think he's the creator of Black and Check, of course, because libcst in PyCon APAC 2023. Yeah, so I forgot to actually introduce myself a bit. So this is me, and I'm from PyCon Taiwan, and first time speaker of PyCon APAC. And yeah, some of the open source project related to me, and the code doesn't actually compile, so yeah. And we are going to hold PyCon Taiwan this September 6th and to TLF, yeah, because I mentioned I'm part of PyCon Taiwan, so, and we are now call for proposal. And here, I'm actually going to lead a sprint of Airflow tomorrow. Here, I'm not sure where the venue actually is, but it's a sprint here, and anyway. So yeah, see where anyone have any questions. Yep, please.
Thank you very much for a very interesting talk. First of all, let me confirm that you created the formatter or linter just from scratch. I mean, like not utilizing existing linter or formatter framework by creating their plugins.
By formatter, you mean which one? The,
for example, like
the class one or the Airflow one? But all of them
either.
are from scratch. Yeah, it's just based on the Python module AST or CST, another module that you can build your syntax tree with more details and yeah.
Oh yes. Features. So So then, my question is it some clear reason why you choose to create formatter or linter from scratch, not using by creating some plugins of existing tools, or are there some like advantages?
I'm not sure where we actually can create plugin to implement this specific rule. Like we need to check where the default value of a certain value is
exactly.
Compile our rule. Yeah, I don't know how we can customize like PyLint or Black or Black to do that.
Yeah, actually, I'm not so familiar with these tools. So yeah, if there are some alternative ways to achieve this similar thing. I would like to just know some like available options to.
Okay, yeah. This I believe this technique is quite commonly used. Yeah, like 2 o'clock. There's another talk about AST that are doing a similar thing as well. And both AST and CST is commonly used in Airflow itself to check whether the contributor come from certain expectations. So yeah, and it's
So other project standard in Airflow, they have been building such custom formatter by themselves.
Yeah.
Okay. Interesting. Thank you.
Yeah. Thanks. Yeah, please.
So it's the first time that I've heard about libcst. I just want to ask how easy is it to migrate from AST to libcst if I only have around maybe 3 node visitors.
I think it's pretty easy because the concept is pretty much the same. You need to know the mapping between the name of nodes, because there's no parameter nodes in AST, and now you can use it in CST. But I think like function definition, class definition, all those kind of stuff in AST should be able to easily port it to CST without many changes, I guess.
Okay.
Yeah.
That's my question. Thank you.
Yeah. Thanks.
Any plans to work on the limitations you mentioned anytime soon?
Unfortunately, I guess not.